What's up, you freaking geniuses? So in this video, I want to quickly cover the differences between these three different graphs, right? So the three different parent functions are written right here at the top. So first we have this cubic function, which is f of x is equal to x cubed. And then here we have the square root parent function. So that's just f of x is equal to the square root of x. And then lastly, we have the rational parent function, or also called the reciprocal parent function, which is f of x is equal to 1 over x. All right, so I just quickly want to go over the differences between these three graphs, specifically their domains, ranges, intercepts, and where they are increasing and decreasing. All right, so let's start, like I said, with the domain and the range of a cubic function, the parent cubic function. So as you can see, first of all, starting with the domain, as we move along the x-axis, there's a function present, right? There's no gap in the function, right? So for instance, if there was a gap in this function right here, right? Like if this function stopped here for some reason and then started here again, well then that means the domain would also have a gap, right? From here to here, there would be a gap in the domain because there's a gap in the function. But with this parent function, we don't have anything like that, all right? It's just a nice clean domain along the entire way, right? We have a function that heads off into infinity in this direction and down in this direction, all right? So since there's always some function along the x-axis, that means the domain, we can say it a couple different ways. We could say it goes from negative infinity to positive infinity, or we could simply say all real numbers, right? And that's the symbol for all real numbers. Now, for the range, we just have to look at the y-axis. And as you can see, there is function along the entire y-axis, right? There's no gaps anywhere. We're not missing anything. So the range here would also be all real numbers, right? Lastly, let's talk about the intercepts and whether it's increasing or decreasing, all right? So let's talk about the intercepts. Well, this parent function only has one intercept, and it's specifically here at the origin. Okay, that's the only spot where this function touches the x and y axis. So it has one intercept at 0, 0. All right, now lastly, let's talk about whether this graph is increasing or decreasing. And the way that you do that is you want to think about a roller coaster. So whenever you're reading a graph, you always start at the point furthest to the left, right? So it's like reading a book, right? You always start on the left side and then you read to the right. So this is the exact same thing. We want to start at the point furthest to the left, which would be this point, and then we want to move to the right, okay? So if we're starting on the left, that means we're starting over here, right? So that means we have to move up along this roller coaster. Up, 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 up. Do, 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 do. So if you're thinking about a roller coaster, you can see we're increasing, increasing, increasing. Now we're increasing a little bit less, right? We're not increasing as fast. It's not as steep here, but we're still increasing. And then here we're going up really fast again, right? It's really steep again. Up, 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 up. Okay, so here we can say that we're increasing along the entire length of the function. So that means we're increasing from negative infinity to positive infinity, all right? Now let's move on to this square root function. So again, we want to find the domain and the range. So as we move along the x-axis, there's no function here, right? There's nothing here covering the x-axis, right? So nothing starts happening until we hit right here at the origin. And then here, as we move along the x-axis, you can see we have function, right? We have a graph. So the domain of this parent square root function starts at 0, starts at the origin. So we're going to put a bracket and put a 0 because we're including 0. And then it moves all the way to the right towards positive infinity, right? So towards positive infinity. Now with the range, it's similar, right? So if we start down here in the negative space, we don't have a square root function anywhere, right? We don't have anything, anything, anything. But again, once we hit the origin, right, and then continue up that way, you can see that we have this function over here. So the range also starts at 0, and then it goes towards positive infinity, right? So it's the same thing for both of them, all right? Now let's talk about the intercepts. So similar to the cubic function, you can see that this graph only intercepts the x and y axis at a single point right here at the origin, right? So it just has a single intercept at the origin at 0, 0. All right, now, is this increasing, decreasing, or neither? Well, again, we always want to start at the point furthest to the left. So in this case, that would be this point right here. Okay, and as you can see, we're going in that direction, right? Up and to the right. So we're going up on a roller coaster, up, up, up. And then here, still going up, here, still going up, just not very much. Okay, here it's only increasing little by little by little by little. All right, it never actually gets flat over here. It just increases little by little by little. So it's always increasing, right? So we're always increasing, starting at what point? Well, starting right here at 0, right? And then all the way towards positive infinity. So similar to the domain and range. So we're going to say from 0 to infinity. Okay, now lastly, we have the rational parent function, or also called the reciprocal parent function. So in any case, it's f of x is equal to 1 over x. And you can see that we have two different graphs right here. So what happens with this parent function is we basically have two asymptotes, all right? So we have one along the y-axis, and we also have one along the x-axis, okay? So these graphs right here in blue get very, very close to these asymptotes, but they never actually touch the asymptotes. Okay, so with that in mind, let's find the domain and range. Okay, so as you can see, if we start way back here at negative infinity and just move along, you can see we have function, right? We always have a function along here, right? There's always this function, right? However, when we get really, really close to the y-axis right here, or in other words, where the asymptote is, you can see that the graph basically turns away and it's never going to actually touch the y-axis, okay? So let's number some of these hash marks to make this a little bit easier. Let's say this is -2, this is -1. So then here, right here, this must be 0. And then here, this is +1, this is +2, +3. Okay, so for the domain, again, you can see we're coming from negative infinity and we're coming all the way over here, right? We have function. But then when we get really close to this y-axis, or in other words, where x is equal to 0, you can see again that this turns away, all right? So the domain goes from negative infinity to 0, but we're going to put a parenthesis around 0 because it never actually touches 0. It just gets super, super close, okay? And then what happens on the other side? Well, you can see on this side, at the top over here, the graph, again, gets really close to the asymptote, but it never really actually touches, right? So again, we can say it gets really close to 0, but it never actually touches 0. So here we're going to say that it gets really close to 0, but it never touches 0. So again, we'll put a parenthesis. And then as we continue on along the x-axis, we have function forever and ever. So towards positive infinity. So we have two different intervals for the domain. And we can group these two intervals using the union symbol. Okay, now it's going to be the exact same thing for the range. So here again, as we come along the y-axis, you can see we have function, right? There's this function that exists. But then when we get really close to here, right, to this side now, where y is equal to 0, well, this function turns away and it's never going to actually touch this asymptote, right, where this x-axis is. So the range also goes from way down here, from negative infinity, and then it gets really close to this line where y is equal to 0. So we'll put a 0 there with a parenthesis since it never touches 0. And then again, we'll put another union symbol. And then on the other side, it picks up again, right? So again, really close to 0, and then up all the way towards positive infinity, like that, all right? So that's the domain and range for a reciprocal or a rational function. Okay, now for the intercepts. Well, this one doesn't have any intercepts. And the reason for that is because, like we said, there's an asymptote on the x-axis and the y-axis. So again, that means that these graphs get really close to them, but they never actually touch, right? So if they never actually touch, that means they never intercept. Okay, that makes sense. So now let's talk about where these are increasing, decreasing, or constant. So again, we want to start at the point furthest to the left. So here, that would be this point right here. Okay, so this is where our roller coaster starts. Now, as you can see, we're already going down, right? Down, 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 and then we go down really fast over here. Okay, so along this entire portion of the graph right here, we're decreasing, all right? So what is this portion of the graph? Well, it goes from negative infinity to, again, really close to where x is equal to 0, right? So if we, again, just number these, so we're decreasing, just abbreviate it, from negative infinity all the way to where we get really close to 0, right? Where we get really close to the y-axis. And then there's a jump, so we go all the way down here and then we magically jump up here, right? So we jump over the asymptote basically, and now we're on this side, right? So then here you can see on our roller coaster, oh, well, we're still decreasing, right? We're decreasing really, really fast. But then here it kind of starts to slow down a little bit, and then here we're decreasing slowly, okay? So along this entire interval, we're also decreasing. So just like the domain and range, we're going to put a union symbol and say we're decreasing from 0 all the way to positive infinity, right? From 0 to infinity. Boom.
So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.